All right, we're looking at 6.3 logarithms. So we've dealt with exponentials. We need a way to reverse it. So there's something called logarithms. If you take chemistry, you've seen logs. Where else do logs come up prevalent? A little bit in physics. You see some logs. What? Yep, you see it in algebra. And honestly, logs come up a lot in real life because you have to reverse exponential equations. So here's the definition of a log. So I'm just going to write a different definition that's a little bit different that a lot of textbooks have. I've always seen it as log base b of x equals y because then it's written in function notation, and that makes more sense to some people. And then if that's true, that means b to the y equals x. Okay? B to the y equals x. Okay? We're going to use that definition a lot. Oopsie doodles. So let's do, now that we know that, we can do these. So when I see a log, this tells me that 3 to the 2 equals x. The base to the what's equal to equals the x. So that'd be 9. I don't know how you're supposed to know this one, but we'll do it. The big thing is knowing the definition. 7 to the y equals 343. Okay? If you can do that part, you understand what a log is. Base to the equals your input. Now, if you didn't know that, that would mean y equals 3. Do I expect you to know that off the top of your head? Absolutely not. No, don't worry about that. This one, though, I need to show you how to do these two. B to the 4 equals 16. Here's what you... I'm going to show you how to do this on a calculator as well eventually, but here's how you would do it if you didn't have a calculator for some reason. I would just go through, and 1 to the 4th power is 1, right? 1 times 1 times 1 times 1 is 4, or 1. It's been a long life. What about 2? What's 2 times 2 times 2 times 2? 16. Right? So B is 2. Okay? All right? B to the 12th equals 9 to the... The most important thing right here is, do you guys recognize how I'm getting this first step every time? That's a lot. That's knowing a lot about logs, if you can see that. Now, how in the world am I supposed to do that? Is 9 a perfect square? Yeah. Could I rewrite that as 3 squared? Yeah or no? So that'd be b to the 12th. What's 2 times 6? Equals 3 to the 12th. So you're basically looking for a lot of perfect squares. So b equals 3. Oh, perfect. I can help you out with those if you get stuck on them. Make sure you know how to do this rule, though. All right. We're halfway through 6.3. Let's do... Now, if you've ever done like chemistry or physics with how loud something is, those are always log or Richter scale of an earthquake. those always, they don't have a number by the log if you're in those science classes and you do them. If there is not a number by the log, it is assumed a 10, okay? On your calculators right now, if you look at them, you have a log button, and that log button is log base 10, okay? So if you ever decibels, if you are a musician or something and you're dealing with an amp, the difference between 8 decibels and 9 decibels isn't 1, it's 10-fold. 9 decibels is 10 times as loud as 8. And then like 1 decibel compared to 9 decibels, that's what, a billion times louder at 9 than it is at 1? Because it's exponential. Same with acid. That's the way acid works, right? A 1 acid is 10 times more powerful than a 2 acid, okay? It's not just a little bit, it's a lot of it. That's why you all can drink like orange juice, and that's like a 2.5 and be fine, but you can't drink hydrochloric acid. You know what I mean? You know what I'm saying? All right. If my base is E, that's called the natural log. Unlike Duraflame, the unnatural log. Get it? Those fake. Never mind. Those are the fake logs you buy at stores. All right. So let's do the same thing we just did. Calculate the right variable for, or right value for the variable. What's my base if it's a natural log? What's down here? Just sneaking around. An E. So it'd be E to the 5.4 equals X. Now that's a number, right? Your calculator has an E button. It rides around its E bike. It's second natural log. I hit the wrong button. Yes, second natural log. You have an E button, so you can plug that in and get an actual decimal if you like. Okay. You guys want to see something really neato? Let's see if we can figure this out. There's an E down here, right? E to the Y equals E to the 23rd. So what's Y got to be? These are both E's, right? Y's got to be 23. We're going to see Y in a second. There's a special thing that's occurring. This has a base of 10. So I'm going to do 10 to the 3rd equals X. And 10 to the 3rd is what, 1,000? Yeah. Uh-oh. Sorry, I didn't mean to be so violent on myself. 10 to the Z equals 1025. Uh-oh, there's no way for me to solve that, right? There's nothing I do with 1025 to make it into it, right? Not yet. Could you, luckily, we have a calculator, and that's what we're going to do the next section. So again, make sure you guys have a calculator and playing along with this game, because it would be a shame to get things wrong in this section because you're using your calculator wrong. Okay, so practice it now. Practice it now. So here's what I like you to do. Actually, this, you guys get with a partner, get with a buddy, and go and plug all these in, see what you guys get with the decimals and compare your answers. What happened here? You guys just discovered some rules. Hooray! We did this already. What do you notice you got, though? 23, 23. Those are going to cancel. The whole reason why we have log is to get rid of exponentials. So we proved that works. What did you notice about these two? Same answer, just one's positive, one's negative. What does a negative exponent do to our number? It flips it, right? So if I take that to a negative exponent, what is it going to do? Flip it. So if I know the log of one thing, I know the log of its reciprocal as well. Now, luckily, if you forget that rule, can you probably use a calculator and figure it out? Yeah. But if you see a problem like this, be careful. You're going to want to go right to your calculator because there's all numbers, and it's talked about. What's your base here? 6. What's your base on your calculator? 10. So this is saying 6 to what power equals root 6? Well, luckily we can do that, right? Because 6 to what power, what can I rewrite a square root as? You gotta see the square root and think of it as a half. Okay, so I can do this. You can do this one without a calculator. Now, I'm going to teach you a way to do this with a calculator later. That'll work anytime you see a change in base. Like, because this one is 2 to the x equals 14. Yeah, that's nothing. You can't do that one yet. You guys do not have the ability to do that problem yet. And that's okay. Oh, we're doing really well. Last, we'll do this. We'll do this one and call it good, and that actually gets us, yeah, that actually gets us through 6-3. All right, I can do this one really, really quick too, but I'll go slow. Let's do this the long way for a second. This one. This is saying there's no equals, right? So I can put an equal x because that's what I'm trying to find. I'm trying to find what this thing equals. Natural log, my base is an e. So it's saying e to the x equals e to the 23. We just did a problem like this, right? What's it equal? What's x got to be then? X is 23. So what you're telling me is these actually cancel out. They're inverses of each other. So if they're inverses of each other, that means it's true both directions, right? If I have e to the natural log of 23, what's going to happen with these two things? They cancel. The answer is 23. That's how I get rid of logs. That's how I get rid of exponentials. So 10 to the log of 5.2, what's my base here? If my base matches my base of my log matches the base of my exponential, what happens to them? They cancel. So that's just 5.2. If the base of my log matches the base of my exponent, what happens to them? They cancel. So that's just 4. Okay? So I could even make like, could I do like log of 10 to the 9.2? What would that equal? What's my base here? 10. I want to show you that it works both ways. So if this base matches that base, these also cancel. I get 9.2. It's saying 10 to what power equals 10 to that power. You don't see that a lot because natural log is going to be the one that comes up a lot. We are going to use this rule a lot. If I were you, I'd star this property. This property right here. Star it, love it, learn it. Big thing with it is make sure your bases match, okay? Too often will they throw a trick question at you where the bases don't match, and then you cannot simplify that problem. All right, there we go.